Hello everyone. Let's discuss about relational calculus. There are two types of relational calculus. One is tuple relational calculus and the domain relational calculus. So this relational calculus, if you can remember your mathematics, it is little similar to it, and we'll be providing the conditions. We'll be giving out the queries. We can't say it's a queries, but we will be giving out these statements in terms of the concerned calculus, whether it is tuple or relational calculus. So now let us discuss about tuple relational calculus. For a relation R, the definition is something like this. For a relation R, tuple variable of T ranges for all the tuples in the relation R. What do you mean by that? R here is a relation, nothing but a table. Tuple determines the row or a record. Okay, remember these two things. So the basic form is written in this way: T1 dot AI1, T2 dot AI2. All these predicate calculus expression are on a condition theta. So what does it determine? T is a tuple variable, and the same thing can be written like this. This is all the expression and this determines the condition. See, if you can remember your query, something like select star from some student table where is a condition clause there, yes or no? Similar, and select star from student is the expression, is a query there. Similarly, that select star from student expression, that is in SQL language. Here we are writing it in tuple relational calculus. Here we'll be using like this, where T, the entire expression, is a tuple variable. We say it belongs to a tuple variable, and condition of T is a conditional expression involving T. Okay, conditional expression involving T. Let us take examples, only then we'll clearly understand what is this. So when you take example, see, let us suppose sailors is a table which consists of these attributes. Now if I wanted to find out all the sailors with a rating above 7, okay, so what am I saying? There is sailors table, as well as it consists of an attribute rating which is greater than 7. I wanted that. So if it is in SQL query, how do you write that? Select star from sailors where rating greater than 7, yes or no? Now, similarly, in tuple relation calculus, you'll start writing like this. You wanted all the sailors. Sailors table is determined by S, capital S, where S belongs to sailors. Yes, we are writing it in terms of yes. So we are saying that S belongs to sailors, and what is that? Rating of sailors should be greater than 7. So S dot rating greater than 7. This simple expression is called as a tuple relational calculus. See if you can understand. This is in the syntax provided. T is a tuple variable. What is that variable here? Sailor table. Within the sailor table, a record. Yes or no? So yes here. Yes is nothing but T, which is a tuple variable. And how are we defining the tuple variable? By saying that it belongs to sailors and condition. And simply condition. This is the expression. This is how you write the tuple relational calculus. Let us go with the other example. Here we need certain things. Find the names and ages of sailors with a rating above 7. You want two things here, that is name and age. You want both those things from the sailors table whose rating is above, again, 7. So sailors table, we have seen it consists of name, age, rating, yes or no. So here also we can say yes, or you can simply use a T is a condition. Okay, T is a tuple variable for which there exists S belongs to sailors, because sailors table, you are using sailors table. And earlier, if you remember, we used only S here, and we said S belongs to sailors and simply rating greater than 7. We have seen rating greater than 7. But now we are taking two other variables, because we are taking another variable T, because you wanted two different values. You wanted to know the two different values, names and ages. So you are taking it and another tuple variable T. As such, there exists yes belongs to sailors, and what are all the conditions? That is yes dot s name, which is from the sailor, should be equal to this particular tuple variable's s name. So you wanted name, that's why you are equating these two things as T dot name is equal to S dot name, And what is the other thing? Age. T dot age must be equal to S dot age, and S dot rating is greater than 7. This is what's because the condition is directly mentioned for this. So I'm using S, the variable S here itself. But coming to these things, you don't have the same condition. You don't have a particular condition. You're simply asked to give out the names and ages. So you'll try giving out in this way: T dot name is equal to S dot name. That means by equating these two things. So wherever I find S dot name, that I will convert it into T dot name. And finally, what do I want? I am storing it in this variable T. In this variable T. So I'll be taking name with respect to this. And what is the other condition? Age. Coming to age, S dot age I wanted, that is available in the table, sailors table. So I want that, and that must be stored into the tuple variable T. So I'm using S dot age, which is equal to T dot age. As such, here now the S dot age will be stored into a tuple variable T that is available here, and you'll be able to retrieve the name and age. As well, there is one more thing with the rating above 7. This is particularly given here. So you'll be using only this particular variable S itself. S dot rating, which is greater than 7. Is this clear? Let us see another example. Find the names of sailors. You wanted the names of sailors who have reserved boat 103. That means here in this case, you will be using sailors and reserves. These are the two tables you will be using, and these two tables must be reflected in our query. Okay, so when you are using two tables, you say there exists S belongs to sailors as well, R belongs to reserves. Okay, and reserves table consists of reserve ID, reserve date, boat ID. Yes or no? So what is the boat ID given here? That is 103. You have given boat ID 103. So reserves table, what does it have? Reserves table, what do we want? We want names and sailors. Okay, reserves table had reserve ID. Reserve ID is available in sailors table. So S dot SID must be equals to reserves dot SID, and the other condition. R dot BID, reserves dot boat. Boat ID, what are there in reserves table? Boat ID is also there. So R dot BID is equal to 103. And what do I want? I want S name, sailor's name. Sailor's name is S dot name. But where it must be stored? It must be stored in the tuple variable, because this is the output value here. So that must be equal to T dot name. So the names of sailors who have reserved boat 103, that is T dot name. T is an output variable, tuple variable, which gives you the output. Now what is output? That is names of sailors. In our earlier example, it is names and ages of sailors. Yes, that is why we had two T dot names and two T dot age. Here only we had T dot name. Okay, and let us see one more example with different condition. See, you wanted the names of sailors, fine, you have reserved red boat. Where do you find the color of boat? We find the color of boat in boat table. Boat table consists of boat ID, boat name, and boat color. Yes, reserves table consists of SID, BID, and reserves date. Yes or no? So what do I want? I want names of sailors. Name of sailor is available where? It is available in the sailors table. So what and all I can do? I should take all the three tables now. That is sailors table, reserves table, and boats table. For each of it, I am assigning some variable like B, reserves, R, and S for sailors. Okay. Now for these things, I'm using the various other conditions, saying that R dot SID, because reserves table consists of SID, BID, and reserves date. So R dot SID must be equal to S dot SID. You don't have SID in B. This is S dot SID. And let us go to this, and then we'll go finally there. And B dot BID, because in both that should be equal to R dot BID, and B dot color is red, and sailor's name, you wanted sailor's name, that should be the output variable. Yes, so S dot name will be stored into the output variable T dot name, because you just wanted the name of the sailor, that's it here. So you are putting that or giving that to the output variable t. As I told you, this is going to give you the output variable. Yes or no? So s dot name will be equal to the t dot name. This is applied when you are able to reach all these conditions. All these conditions. Those conditions are SID from reserves must be equal to SID from sailors. Imagine the table there. And BID from boats must be equal to BID from reserves, because reserves table consists of BID and boat table also consists of BID and boat dot color. See if you can understand one thing. Here you have used boat ID and you have used boats table. In our previous example, though you used boat ID here, you did not use boat table. You just used two tables, sailors and reserves, but you did not use boats here. Whereas here you used boats. What is the reason? The reason is, if you consider boat ID alone, boat ID can be obtained from the reserves table, because reserves table consists of SID, BID and reserves date. But when you consider this particular condition called red boat, the color of the boat is not available in either sailors table or reserves table. It is available only in the boats table. So if you wanted red colored boat, if you wanted to use this red color, the color of the boat, then you have to surely go for the usage of boats table also. So boats table B dot color is equal to red. B dot color from boats table I took this thing. Yes. From reserves table and boats table, boat dot BID is equated to reserves dot BID and reserves dot SID is equated to sailors dot SID. And what do you want? You want names of the sailors. Name of the sailor is an output statement that will be stored in T as a result T dot S name. But where is actually sailor name? That is available in sailors table. As such, say S belongs to sailors, so you are using S dot name. Simple. This is what is tuple relational calculus, and these are various examples. Now coming to the other type of relational calculus called as domain relational calculus. Here you will be using a domain variable. In earlier tuple relational calculus, we have used a tuple variable. Here you will be using a domain variable. So when you say a domain, it determines the range of values in the domain of some attribute. It determines the range of values. So the entire expression also will be in terms of these ranges like x1, x2, x3, so on up to xn, where these are all the domain variables, and the formula is p of some this x1 is the same things. This is the predicate. Okay. So this formula determines the domain variable. See, let us see an example. Sailors table consists of SID, name, rating, and age. What do we do is, while dealing with the domain relational calculus, we'll be specifying all these terms in terms of a single letter. If it is SID, I, name, N, rating T, and GPA, some A, something like that. It can be even R, no issues. So you'll be specifying each attribute with a single letter. So let's see the examples. You'll better understand through examples. What do you want? You want all sailors whose rating is above 7. Same thing. So what do you want? You wanted all sailors. So what are all the range of values available in sailors? Those are INTA. Specify those domain ranges here, because you are dealing with domain relational calculus. That means it will be dealt in terms of all the domain values. The domain value is nothing but the attribute values. So INTA, as such, INTA belongs to whom? Belongs to sailors. And what do you want? Greater than rating, which is greater than 7. T determines rating here. T is not a tuple variable, something which I have seen in the tuple relational calculus. No, T is a rating which we define. So T is greater than 7. Now find the names of sailors who have reserved boat 103. That means the boat ID is given. And you are dealing with domain relational calculus. As such, you will be dealing with domain ranges, remember. So What do you want? You want names of sailors, that is N. Sailor name is determined by N, yes or no? Here in our this thing, name is determined by N. So N, and what are all left besides N? ITA, ID, rating, and GPA. There exist these three things from what? From INTA, who belongs to sailors, as well as what is asked here, reserve boat 103. That means boat ID is given. Boat ID is available in the reserves table. So I'll be using the reserves table. What are all there in reserves table? You have SID from reserves table and boat ID from reserves table and date of reservation. Yes or no? So IR, SID is determined as IR in reserves table. IR, BR, comma D. These are all the three domains, range of domains. There exist these three domain ranges, the domain values in domain ranges which belongs to reserves. And what am I saying? Boat 103. In order to link from reserves boat to sailors boat, first of all, R dot SID must be equal to S dot SID. If you remember your tuple relational calculus. So R dot SID is nothing but our IR and S dot SID is nothing but our I. Yes or no? I. And what is the other thing? Boat 103, which is available in the reserves table. That is BR. BR is equal to 103. This is how you determine the domain relational calculus. Okay. This is what is SID name. The IR reserves SID. Reserves BID is BR and day is date. Nothing but D. BID is simply B here because it belongs. This is the ID of boat system, so it's simply B. The same BID here, but it belongs to reserves table, so we are differentiating it with BR. The same SID here, but it belongs to reserves table, so I'm differentiating it as IR, B name and color. Okay. Coming to the next example. What do we want? We want names of sailors who have reserved a red board. That means here again we had color here. When you have color, that means you are using boat table also. As a result, you should use all the three tables. You should define all the domain values and the ranges as well. What do you want? You just wanted only the names of sailors. So just bring it out, name of a sailor, where besides this name of a sailor there exists ITA from the domain ranges INTA which belongs to sailors and who have reserved. So you are using a reserve boat. Reserve boat consists of IR, BR and D as well. Boat consists of boat ID B, comma BN is the boat of the name and B color is red. Red directly I have defined here because it is reflecting directly, right? So I defined red color. These all belongs to boat. From this particular range of domains, I need to find out the name of sailors. This is what it determines. This is what is domain relational calculus. So if you consider tuple relational calculus, the tuple relational calculus determines the tuple values, tuple variables and its range. Coming to the domain relational calculus, it defines about domain values, their attributes and the range of all the domains available in a particular table. Okay, depending upon the query, we keep on increasing the number of domain values, domain attributes. Suppose in this example, if it is asked like find the ID comma name of sailors. If that is the case, in that case, you'll have to write here I comma N. There exists T. That is T is nothing but rate, rating, and A is nothing but GPA because I comma N has come here from the domain ranges INTA which belongs to sailors. Okay, and at finally what will you write is one more condition, there exists boats, and one more condition is because you wanted ID also, R dot IR must be equal to I. From there we can obtain I value. Is this clear? This is how it comes to or it turns out in domain relational calculus. While writing in examples, this particular expression is must with respect to domain relational calculus as well. According to tuple relational calculus, this is also must its own definition. Tuple relational calculus, this basic form as well as this definition is important for tuple relational calculus. These things you should remember, understand, and write in the examination. Hope you all understood well. Thank you.